Hello, all my 9th standard young friends. This is the annual examination, that is the pre-board examination paper of class 9 2020, which means the pre-board's examination that finished this year in the month of February 2020. This is the mathematics paper. The paper is for 2.5 hours, and also with first 15 minutes given to you to read thoroughly. And then we have two sections. We have section A, which is 40 marks. Section A has 4 questions, each 10 marks. So question 1 to question 4, they will be of 10 marks each. Mostly the marking scheme is 3, 3 and 4 marks. Okay, then our section 2 will have 7 questions. We have to attempt any 4 of them. So when we get our first 15 minutes, ideally you should read section B first and decide on which questions we want to attempt, where we will lose the least marks, and then we come to question number 1. Now, are we ready to solve the question paper? Let's begin. Our question 1 of section A starts with rationalizing. Can you see this 4 upon root 5 plus root 3? We have to simplify this and find the value of this fraction. And we have been given root 5 and root 3 values. So how we start with this? By rationalizing this fraction. So we have written the question down. Now we will write the fraction the way it is given. And because the denominator is of the form a plus b, we will rationalize it with the form a minus b, which means root 5 minus root 3, and the numerator also will be just the same. That will give us in the denominator root 5 whole square minus root 3 whole square, because we are using a plus b into a minus b equal to a square minus b square, and in the numerator we have that will now simplify it as 4 into root 5 minus root 3 upon root 5 whole square is 5, root 5 into root 5, minus root 3 whole square is root 3 into root 3, which is 3. That would give us 4 into root 5 minus root 3 upon 2. 2 1s and 2 2s will give us. Now, just to save on space, I am going to make a column. In the exam, please continue to write one step below the other. But here, just to save on space, I will use the column. So it will now become 2 into bracket root 5 minus root 3. Now, this apparently is the answer if they had not given us these values. So now we will have 2 into root 5 is 2.236 minus 1.732. So it becomes 2 into bracket 6 minus 2, that is 4, 3 minus 3, 0. And when we multiply by 2, and this is our answer. Let us look at question number 1b. If x minus 1 upon x is equal to 1 upon 3, evaluate x cube minus 1 upon x. And now let us solve this. We have been given x minus 1 upon x is equal to 1 upon 3, and we want x cube minus 1 upon x cube. So we will have to take the cube of both sides. So we use the formula for a minus b whole cube. A cube minus b cube minus 3ab into bracket a minus b. This is the formula for a minus b whole cube equal to. So this is our thinking step. We will use just this and we will now write our next step. Therefore, x cube minus 1 upon x cube minus 3 into x into 1 upon x into x minus 1 upon x, and that is 1 upon 3 whole cube. 1 cube is 1, 3 cube is 27. Now we have therefore x cube minus 1 upon x cube minus, it will be 3 into bracket x minus 1 upon x, which is 1 upon 3, and that is, so as you can see, we have this minus 1 transferred this side. You will have 1 plus 27 in the numerator. That gives us 28 upon 27, which is the answer, but we will write it actually as 1 and 1 upon 27. We convert it into a mixed fraction and we write it as our answer. Question 1c. In the given figure, ABC is the triangle, D is the midpoint of BC, AD produced 2E. Let us look at the diagram. AD is produced to E. Can you see that? AD is produced to E, and BM and CN are two perpendiculars dropped from B and C. Can you see that? BM and CN, they are the perpendiculars dropped on AE. We have to prove that triangle BMD is congruent to triangle CND, and the second, BM equal to CN. Question 1c, we have drawn the diagram. We have BM perpendicular to AE and CN is perpendicular to AE, and we write what is given like so and what is to be proved, and then we will have the statements and the reasons columns. Statement number 1 saying D is midpoint of BC, which is given. Statement number 2, BM is perpendicular to AE. Statement number 3, CN is perpendicular to AE, and all this is given. Statement number 4, we take BMD triangle, which I will show with the dot, and CND triangle, which will be shown with the tick mark here, and you will see that this is 90 and this is 90 in these two triangles, and then we will have these two angles which are vertically opposite, and D is the midpoint of BC, so this is equal to this. So it is your AAS, or you can write it as SAA. So let us write in triangle BMD and triangle CND. Now you pause this video and write down the angles which are 90 degrees, and here I am writing the reason. BM perpendicular to AE, CN perpendicular to AE, which is statement 2 and 3. Now look at your answer. It is BMD is equal to angle CND which is 90. Then we come to statement number 5. Again, pause it. The two angles which are vertically opposite. Okay, now check your step. It will be MDB and NDC. Did you get it right? Good. Statement number 6, we will have BD equal to CD. This will be because of statement number 1, because D is the midpoint, correct? And 7th statement, therefore, can you see this is your A, this is your A, and this is your S? The test for congruency, triangle BMD is congruent to triangle CND, and this will be because of statement 4, 5, 6. And AAS, test for congruency. All right? This is your proved first part. Okay? Now we have to prove that BM and CN, they are equal. Now these two sides are opposite these vertically opposite angles. Can you see that? So they are the corresponding sides, and corresponding sides of congruent triangles will be equal. Statement number 8. Therefore BM is equal to CN, and this will be from statement 7, and C, P, C, T, C, corresponding parts of congruent triangles are congruent, and that is your proved 2, and we put it in a box. And so we have finished with question number 1. Question 2a says evaluate, and this is given. This is from chapter indices, and so we are going to just copy this and we are going to use the laws of exponents and we are going to solve this. We have minus 1 upon 4 bracket to the power minus 2 minus 3 into this we will write as 2 to the power 3 and that to the power 2/3 multiplied by 4 to the power 0 is 1 and plus it will be here 3 to the power 2, 16 is 4 to the power 2 and the whole bracket is to the power minus half. That is equal to, now we are going to make this negative power into positive by making a reciprocal of this, because x to the power minus m will be 1 upon x to the power m, right? So it will be minus 4 upon 1 to the power 2 minus 3, and now this and this will multiply, so we will write it like so. This multiplied by 1 does not make any difference. Here this is again negative power, so we'll make it as positive. So 4 square upon 3 square bracket to the power half. This gives us minus 4 square becomes 16 minus this gets cancelled, 3 multiplied by 2 to the power 2 and plus here this is 4 upon 3 bracket to the power 2 and that to the power half. So we will have 16 minus 3 into 4 plus this will be, now 2 into half will get multiplied and we will have plus 4 upon 3. That is 16 minus 12 plus 4 upon 3. That gives us 16 minus 12 is 4. So it will be 4 plus 4 upon 3 is 1/3. You can take LCM also, not a problem. So I am just going to stop at this and this is our answer. So here we have question 2b. Using ruler and compass only, construct rhombus ABCD with AB equal to 6 centimeters, diagonal AC 7 centimeters, and hence measure and write down the length of the diagonal BD. So first we will draw the rough diagram. I'm just going to show a rhombus. Each side is 6 centimeter. It was given to us, and diagonal AC is 7 centimeters. Once we draw the diagram like this, it is easier for us to understand the construction. We will draw AB first, then we'll take the radius 6 centimeters, draw the arc, 7 centimeters, draw the arc. So you'll get your point C. From here, we'll take 6 centimeters. From A, we will take 6 centimeters. Where they intersect, that will be our point D, and then we join this. Okay, so let us see how we can do this. That is your 6 centimeters. Now we will take the radius equal to, let's check this, is it 6? Okay, so we've taken 6 centimeters as the side. Now we will take 7 centimeters as the radius. There it is 7, and now keep the point of compass at A and draw an intersecting arc. So you see, I should have taken longer arc. So this is our point C. From C we need, this is 6 centimeters, yes. So from here 6 centimeters we draw the arc, and from A 6 centimeters we draw the intersecting arc. So we have this is point D. Now we will join we write the measures and we are asked to find the length of diagonal BD. Now because AC we have taken as 7 centimeters, I shall show this as dashed line, and diagonal BD we have to measure. So I will draw that diagonal and let us measure. I'm getting it as 9.6 or 9.7. It is between that. So we will write it as 9.7 centimeter and we will say BD equal to 9.7 centimeter. Now your examiner will have to give you marks even if it is 9.6 that you have written, because it is between 9.7 and 9.6 for me. So plus and minus a little bit of error is still agreeable and you will not lose your marks for that. Let us come to question number 2C. Mr. Ram borrows rupees 20,000 for 2 years compounded annually. The rate of interest for 2 successive years are 9% and 10% respectively. If he repays rupees 1,200 at the end of first year, 1,660 at the end of second year, find the amount outstanding at the beginning of the third year. So we've written the data here. The principal, that is the amount borrowed, is 20,000 times 2 years. R1, that is the rate for the first year, is 9%. R2 is 10% per annum. Amount repaid after 1 year is 1,200. Amount after second year repaid is 1,660, and we have to find out amount outstanding at the beginning of third year. So for something like this, I prefer to do P1, that is principal for the first year, that is rupees 20,000. Then your I1 is going to be 9%. So I will say I1 will be PRT upon 100, which is 20,000 multiplied by 9 into 9 to is 18. So we have the interest as 1,800. And so the amount after first year is rupees. Correct? Now we are going to have amount repaid after first year 1,200. So we will have amount outstanding we'll have to subtract this from here. Correct? Now this becomes the principal for the second year. So let us see how we do that. Your principal for the second year is rupees 20,600 and the interest for the second year will be, rate for the second year is 10%. Second year means time is 1. So the interest is 2060, and so we'll have the amount at the end of 2 years. The second year it's going to be like so, and now we will have amount repaid is going to be rupees 1660. So amount outstanding will be, when you subtract this from this, so it will be 0, 0, 0. Now we want the amount outstanding. If you look at the question, we need amount outstanding at the beginning of the third year. It means end of second year. Amount outstanding at the end of the second year, which means beginning of the third year. So 21,000 is your answer. Let us look at our question number 3. Without using the trigonometric tables, evaluate the following, and we have been given this. Now, without using trigo table means that you cannot use the log table to find out like tan of 30 or tan of 60. You cannot use the table, but you will have to use the standard angle table. Okay, first of all, you must have the standard angle table ready for this. So let us see how we solve this. Okay, question 3a, let's write it down. For our standard angles, we will write the standard angle 0, 30, 45, 60, 90. This is what you have to do in rough. This will be 0, half, 1 upon root 2, root 3 by 2 and 1. And then we will write 1, root 3 by 2, 1 upon root 2, half, 0, 0, 1 upon root 3, 1, root 3 and infinity. Now you need to know this by heart. Okay. Now in case you do not know the shortcut for this, I will put the link up somewhere on the right hand corner. So you will be able to see that video and know how to get the trick of remembering these values for the standard angles. Let us come to our question number 3. Now tan 30 is 1 upon root 3. And so cot becomes root 3 upon 1. Sec is 1 upon cos. Cos 30 is root 3 upon 2. So sec becomes 2 upon root 3 plus cosec is 1 upon sine. Sine 30 is half. So cosec becomes 2 upon 1. Tan 45 degrees is 1 minus 2 multiplied by cos 0 is 1. So 2 into 1. Sine 30 is half plus cos square 45. Cos 45 is 1 upon root 2 and that whole square. Now let us simplify this. Root 3 multiplied by root 3 upon 2 plus 2 minus 2 into 2 upon 1 plus 1 upon root 2 square. 1 square is 1, root 2 square is 2. So we have 3 upon 2 plus 2 minus 4 plus half. Okay, now I'm going to take this and this together. This will be 1.5 and half, that is 2. So I'll have this plus this, that is 4. 4 minus 4 is equal to, and that is our answer. Now let us come to 3b. Question 3b. Triangle ABC is right angle at B. M is the midpoint of BC and prove that AM square plus BC square is equal to AC square plus BM square. Let us draw the diagram and then we'll start solving it. So we have drawn the diagram and we have written what is given over here. Now we have to prove that AM square plus BC square. AM is the hypotenuse for this triangle. So we will say in right triangle ABM by Pythagoras theorem, we will have AM square is equal to AB square plus BM square. Okay. Statement number 2. They want BC, the square of it. BC is the part of this big triangle and that's also a right triangle. So in right triangle ABC by Pythagoras theorem, we will have AC square is equal to AB square plus BC square. And so statement number 3, we are not interested in AC square, we need BC square. So BC square is equal to AC square minus AB square. Statement number 4, we will take AM square plus BC square will be equal to AM is AB square plus BM square plus BC square is plus AC square minus AB square. Okay, which is equal to BM square plus AC square. Isn't that what we needed here? Okay, so this will be from statement 1 and 3, and this is where we say we proved AM square plus BC square is equal to BM square plus AC square. 3c. Construct a frequency polygon for the following distribution. Use a graph sheet. So this is our distribution table. We'll have marks which will be on x-axis. Number of students will be on y-axis. Marks are up to 90 and number of students maximum are up to 34. So let's get the graph sheet. Pause the video. Now draw the graph and match it with my solution. So 3c question is about frequency polygon and you will see that I have taken, this is your y-axis and I have taken the number of students. So I'll write here number of students. Okay, and you will see number of students, the highest is 34. So you will see that I have taken, you see, this is 20, this is 25, this is 30. Now this is a 2 millimeter graph. Between 20 and 25, there are 10 divisions. So each unit becomes 2 divisions. This is 21, this is 22, this is 23, this is 24, and this is 25. Okay, got that? Alright. On the x-axis, I have taken, as you can see, the values start from 30 going up to 90. So I have the values up to, there are 10 squares here. So this is 100, this is 90, 80, 70, 60, 50, 40, 30, 20 and 10, and this is 0. So this is the origin, which I'll write as O, and these are the marks. And we have taken 2 centimeters as 10 units. Okay, which means each one of this is 1 unit. So this will be 11, 12, 13. In any case, marks are given as a group. So 10 to 20, 20 to 30. Now 30 to 40, the frequency, that is number of students, is 6. So from here to here, this is 5, and then 2 divisions, so that is 6. Okay, now between 40 and 50, it is 15 students. So we come up to, this is your 10, this is your 15, and this is how we make the rectangles. All right, we come up to here. Then 50 to 60, it is 28. So after 25, this will be 26, this will be 27, and this will be 28. So we draw the horizontal line, and then we will take this vertical line to make this rectangle. And then out here, this is 34. So you will see that this is 30, this is 35. So I come down 2 divisions. So that is my 34. I complete this rectangle. The next one, 70 to 80, is 18. So 18, this is 20. So this is 19 and this is 18. Or you can count from here 15, 16, 17, 18, make this rectangle. And then 80 to 90, the frequency is 8, that is 8 students. So this is 5, 6, 7, 8. Or you can come down, this is 10, this is 9, this is 8, and make this rectangle. Now this is actually histogram that we have drawn if we make the blocks like so, the rectangles. Frequency polygon says that you take the midpoint of this class interval, midpoint of class interval. So you'll take the 5th division and mark it as a dot. For the first one, 30 to 40, the earlier class interval would be 20 to 30. So you mark the 5th division. All the midpoints of these are marked. For the last one, 80 to 90, you go ahead to 90 to 100. Mark the 5th division here. And keep all these points ready. And all you have to do is just join them like so, with a straight line, okay, with a ruler, and that is how you get your histogram. Now you will see that out here I have written the scale. Okay, can you see the scale that is written over here? So it should be written like so. All right, let's look at question 4a. A is a point on the x-axis and B is minus 7, 9. Distance between the points A and B is 15 units. Find the coordinates of point A. Now out here, you'll have to first draw the diagram. So let's just do that. Let's see the statements also. A lies on x-axis, and so let A equal to x comma 0. Remember, if the point is on x-axis, it becomes x comma 0. If it's on y-axis, it becomes 0 comma y. And we show the diagram like this. We write A as x comma 0, B as minus 7 comma 9, and the distance is 15 units. And so, because we are going to use the distance formula, all of you should know the distance formula by heart. Now remember, A is x comma 0, so we would have to have x minus minus 7. So my formula will not be x2 minus x1 whole square and y2 minus y1 whole square, but I'll keep it as x1 minus x2 whole square. We use the formula d equal to under root x1 minus x2 whole square plus y1 minus y2 whole square. Now we have to specify what is x1 and y1. So we write it like this. Okay. And then all we have to do is substitute. Your distance is 15. So under root x minus 7. Okay. And here it will be 0 minus 9. All right. So when we are writing the next step, it becomes 15 equal to under root x, minus into minus becomes plus 7 whole square, and here 0 minus 9 is minus 9 whole square, and so it becomes 15 equal to under root, this becomes x squared plus 14x plus 49, and here it becomes plus 81. We are using a plus b whole square formula, which is a square plus 2ab plus b square. Now we are going to square both sides. So 15 square will be equal to, this we write without the square root sign. So x square plus 14x, and 49 plus 81 is 130. 15 square is 225. This we write as it is. Take 225 that side. So you will have 0 equal to x squared plus 14x minus 95. Okay. Now we have to factorize this. So we have x squared plus 14x minus 95, and that's equal to 0. So we will now write our product is going to be 1 into minus 95, that is minus 95, and we will have difference equal to minus 14. The factors of 95 will be 19, 5's 95. So minus 19 and plus 5. Okay. So x squared minus 19x plus 5x minus 95 equal to 0. So x into x minus 19 plus 5 into x minus 19 equal to 0. So x minus 19 into x plus 5 equal to 0. So x minus 19 equal to 0 or x plus 5 equal to 0. That will give us x equal to 19 or x equal to minus 5. Therefore, A, which is going to be x comma 0, is 19 comma 0 or minus 5 comma 0. So these are the coordinates of A, and that is our answer. Question 4b is a geometry diagram. This one. Let us read it. In the given figure, ABCD is a rectangle whose diagonals intersect at O. Diagonal AC is produced up to E and angle DCE is 145. Find angle CAB, that is this one, AOB, that is this one, and ACB, that is this one. Okay, so first of all, we'll need to draw the diagram. Let's draw it. 4B diagram is ABCD is a rectangle and AC is produced, and this angle over here DCE, that is 145. We are to find out angle CAB. CAB is this, so I'll call that as small a. AOB, which is this, I'll call that as small b. ACB, this is a small c. So these are the angles we have to find in our given and find. We will write what is already given in the data, and then we will write the statements and the reasons. The first statement, we will write what is given. ABCD is a rectangle given. Now when it is a rectangle, we know that all angles are 90 degrees, so we write that. Statement 1, since angles of rectangle are 90 degrees each. And also we know for rectangle, the diagonals bisect each other, and the diagonals are also equal to each other. So we will write AC, which is diagonal, and BD, which is also diagonal of ABCD, and these diagonals are equal because it's a rectangle. Now, angle DCA, that is this angle over here, this 145 and this. So we are slowly going from 145 this way. Okay. So 145 and this. What is the connection? They are angles in a linear pair. So we write that. So DCA, this one is going to be 180 degrees minus 145, which is 35, because angles in a linear pair are supplementary. And so angle DCA, that is this one, will be equal to angle CAB, that is this one. This and this, they will be A and A because they are alternate angles. Why? Because your AB and DC, they are parallel to each other, and so we will have alternate angles are equal and that's why even angle CAB will be equal to 35 degrees. So if I am looking at this angle, I need to know this angle, which is, we have found out that this angle over here is 35 because this angle is 35. So now if I have to find AOB, that is the second one, then I need to look at this triangle. Now in this triangle, I need to know AO and BO. They are going to be equal. So this will be 35, this will be 35 degrees. So we will write AO equal to BO. This statement number 3, which says AC equal to BD, we'll write therefore AC upon 2 is equal to BD upon 2. That is statement number 3. Now AC upon 2 means half of AC, and half of AC will be AO, and half of BD will be B. Therefore, in triangle AOB, look at your triangle AOB, we will have AO equal to BO, and therefore opposite AO will be angle ABO, and opposite BO is going to be angle BAO. They are equal to 35, 35. This angle plus this 35 plus this 35 will be 180 degrees, since angles of the triangle are supplementary. So see how we are writing it. You have the diagram in front of you. You have drawn it already, right? Statement number 6, as diagonals of the rectangle bisect each other, then in triangle AOB, angle ABO equal to angle BAO equal to 35 degrees. From statement 7, as angles opposite to equal sides are equal, and also from statement 5, which says these two angles are 35, and the diagram. Then we will talk about the 3 angles of triangle AOB being supplementary. We write equal to 180 degrees. See there? And so we substitute 35, 35 and AOB equal to this. And so we will have 70 degrees plus AOB equal to 180 degrees. So AOB turns out to be 180 degrees minus 70, which is 110 degrees. And that's our answer 2. Now we have to find this angle, this one, C. So we will take this triangle. Which one? Triangle ABC, because we already know that this angle over here is 90, this is 35, and this one, if you add to this, you will get angles of the triangle ABC. They are supplementary, so we write just that. So in triangle ABC, the 3 angles add up to 180 degrees because angles of the triangle are supplementary. And so 35 degrees plus 90 plus ACB equal to 180 degrees. That will be from statement 5, which said that the angles are 35 degrees each, and statement number 2. So angle ACB therefore is, these two go that side, 180 degrees minus these two, that will be your 55 degrees. And that is our answer 3. Question 4C. Find the altitude and area of an isosceles triangle whose perimeter is 64 centimeter and whose base is 24 centimeter. When we start solving something like this, remember tip number 1 is always to draw the diagram. So let's just do that. A diagram looks like this, triangle ABC, and it's an isosceles triangle. So we will show AB equal to AC, and we will call that as small a and small a. And the base we will call as B. Now we are given that the perimeter is 64 centimeter and the base is 24 centimeter. Perimeter is going to be AB plus AC plus BC. So it will be, in terms of A and B, it will be A plus B, correct? So 64 is equal to 2A plus base is given as 24. So we connect what is known with what is unknown, and so 64 minus 24 is equal to 2A. 2A turns out to be 40. A turns out to be 40 upon 2, that is 20 centimeter. Now we are expected to find the altitude. So altitude means you'll have to drop the perpendicular. So we will draw AD, which is perpendicular to BC. Let AD be the altitude. So BD equal to DC will be half of BC. See there, this BD equal to DC, that will be half of BC, because altitude from the vertex bisects the base. So each one of them will be half of 24. So we write like so. Okay, so this is 12 and this is 12 centimeter. Got that? Now, in a triangle ADB, Pythagoras theorem will give us, now we know, see, A is 20, So this is 20 centimeter. This is 12 centimeter. So using the Python theorem, we can find AD. So in triangle ADB, by Pythagoras theorem, we'll write hypotenuse is equal to sum of the squares of the other two sides. It's very simple. We are just substituting the values. Now when you are doing this, you have to draw the diagram first. Put it on pause, write it on your own and check with me whether you are right or no. Okay, and check the steps also so that the logical sequence also can be understood better that way. So AD square will be equal to 400 minus 144. That will give us 256. So AD will be under root that, and 16 square is 256. So we are going to get AD as 16 centimeters, which is the altitude, and that becomes our answer 1. Now, the second part they asked us is to find the area. So area of triangle is half base into height, correct? So that is half BC into AD. And so you will have half 24 into AD is 16, and that is 192 centimeters square, and that is our answer 2. Section B, which is 40 marks. And from this section, we have to attempt any 4 questions. We are going to start with question number 5. 5A reads, if 13 sine A is 12, find sec A minus tan A. Question 5A says 13 sine A equal to 12. So we convert it into sine A equal to 12 upon 13. We draw this diagram and we will see this is our angle A, and your sine A is opposite upon hypotenuse. So opposite becomes BC, which is 12x units, and hypotenuse AC becomes 13x units. And then in this right triangle, we use Pythagoras theorem, and then we use AC square equal to AB square plus BC square. As you can see, this AC square is equal to AB square plus BC square. And substitute the values, and we will get our AB square as 169x squared minus 144x squared. So AB becomes under root of 25x squared, which is 5x units. So we will write here 5x units. Now we have to find the value of sec A minus tan A. Now sec A is 1 upon cos A, correct? And tan A, we know it is opposite upon hypotenuse. So cos is adjacent upon hypotenuse. So I shall write it as 1 upon 5x upon 13x becomes 5 upon 13, minus tan A is going to be opposite upon adjacent. For A, opposite is BC, that is 12x upon 5x, that is 12 upon 5. So we will write like so, and that will give us 13 upon 5 minus 12 upon 5, and that is 1 upon 5, and that is our answer. Question 5B reads, a sum of 10,000 rupees yields rupees 3310 as the compound interest in 3 years. If the interest is compounded yearly, find the amount and the rate of interest. So we have written 5B, principal, that is 10,000 rupees. Compound interest in 3 years is 3310 rupees. Find the amount. Now what is your amount? Your amount is going to be principal plus the compound interest. So that will be 10,000 plus 3310. So that will be 13,310 rupees, and that is our answer 1. Okay, now we come to the second part. The second part asks us rate of interest. So we are going to connect amount with the principal, and our formula is A is equal to P into bracket 1 plus R upon 100 to the power n. So amount we have already found out. It is 13310 is equal to principal is 10,000 into bracket 1 plus R upon 100. And remember, we have been given CI for 3 years, so n becomes 3. Now we are going to take this 10,000 this side. So 13310 upon 10,000 is equal to 1 plus r upon 100 to the power 3. 0 gets cancelled. Now if this is a cube, this must be a cube, and we know that it is the cube of 11 upon 10, and that is equal to 1 plus r upon 100 to the power 3. So you will see that the powers are same, so the bases must be equal. So taking cube root, we will have, now we transfer this one this side, so it becomes 11 upon 10 minus 1 equal to r upon 100, and so we get 1 upon 10 equal to r upon 100. So your r is going to be 100 comes this side, and therefore your rate is equal to 10% per annum, and that is our answer 2. Question 5c. In the given figure, O is the center of two concentric circles. A line L cuts the circle at ABCD. This is line L cuts the circles at ABCD as shown in the figure, and OP is perpendicular to AD. This OP is perpendicular to AD. Given that OA is 34, this is 34 centimeter, OP is 16, and AB is from here to here, this is given as 18 centimeter. Find the length of the chord AD, this full thing, then the length of the chord BC from here to here, and the radius of the smaller circle, which will be OB. So we will be joining this when we draw this diagram. So let's draw the diagram and see what we can do. We have drawn the diagram here. You can see AD is the chord of the bigger circle, BC becomes the chord of the smaller circle, and these are concentric circles. We have been given OA is 34. So I shall write here 34 centimeter, OP is 16, and AB from here to here, this is 18 centimeter. Okay, now we have to find AD. AD is going to be twice of AP. Reason, OP is perpendicular to AD, and therefore the perpendicular from the center bisects the chord. So we shall write just that in our first statement. We will say that OP is perpendicular to AD, and that is given. Statement number 2, therefore AP equal to PD equal to half AD, and this will be from statement 1 as perpendicular from center bisects the chord. Now AP can be found out using this triangle. So we know that this OP is perpendicular, so this becomes a right triangle. So in right triangle APO, by Pythagoras theorem, we will have AO square equal to OP square plus AP square. Now we have to substitute. What I want you to do is draw the diagram, put it on pause, and then look at the solution, because each time I don't want to move this paper to show you the solution. So we are substituting. AO is 34 square equal to OP is 16 square plus AP square as it is, and so AP square will be equal to 34 square minus 16 square. So I'm going to make it as 34 plus 16 and 34 minus 16. This gives me 50 multiplied by here it will be 18. So my AP will be under root that. So this will be under root 2 into 25 into 2 into 9. That will give me 2 into 5 into 3 as the value of AP. AP will be therefore 30 centimeter. Now we are asked to find AD. So you will say statement number 4. So your AD is going to be equal to twice AP. Statement number 2. So AP is half AD. So AD becomes twice of that. So 2 into 30, which is equal to 60 centimeter. And that is our answer 1. Now the second part says BC equal to how much? So let us look at our diagram. We want BC, so we need to use triangle BPO. From here to here, this is AP, and AP came out to be 30 centimeter. So your BP will be from here to here. This is going to be 30 minus 18, and that will be 12 centimeter. So in this triangle, you can find BP is 12. So BC is going to be double of that. Okay, so we come to statement number 5. We will say that BP is equal to AP minus AB because of the diagram. Now AP is 30 centimeter minus AB is 18 centimeter, and this will be from statement number 3 and given, which comes out to be 12 centimeter. Now this is your BP. Now if you look at your diagram, you will see that OP is perpendicular to BC as well. So let us write it OP perpendicular to BC, and here it is again given. So seventh statement will be your BP equal to PC equal to half BC. This will be from statement 6 and perpendicular from center bisects chord. Bisects the chord. Alright, so you will have therefore BC will be equal to 2BP, which is 2 into 12, which is 24 centimeter, and that becomes our answer 2. We have to come now to finding the radius. Now let us look at the diagram. In a triangle OPB, you will see that OB is the hypotenuse, OP is 16 and BP is 12, and OB is the radius of the inner circle, the smaller circle, correct? So this is nothing but OB equal to question mark. So we will take this triangle, which one? OBP. So we've written just that. In write a triangle OPB by Pythagoras theorem, OB square is equal to OP square plus BP square. OP is 16, so that is 16 square plus 12 square, which is BP square. 16 square is 256, 12 square is 144. Add them, you get 400. OB will be under root that, which will be 20 centimeter, which is the radius of the inner circle, and that is our answer 3. That finishes our question 5. Now we come to question number 6. A. If the mean of the observations A plus 6, A plus 2, A plus 8 and A plus 4 is 11, find the value of A and the median. So first of all, we will write all these observations. We'll write what is the mean, and then we'll proceed to find A. So we've written mean 11 and the formula for mean, because if mean is given as 11, we need to know the formula for mean, which is sigma x upon n. What is x? X represents the observations. How many observations are there? 1, 2, 3, 4, 5. So that is going to give us here, mean is 11. So 11 into 5 is 55 is equal to 1, 2, 3, 4, 5. So 5A plus 6 and 2, 8, 8, 16. 16 and 4, 20. Okay, then we will have 55 minus 20 is equal to 5A, and that will give us 5A is equal to 35. Therefore, A is equal to 35 upon 5, which is equal to 7. So your A is equal to 7, and that is our answer 1. Now this was our first part. The second part asks us to find the median. Okay, so we are going to write these values as 7, then 7 plus 6, then 7 plus 2, then 7 plus 8, then 7 plus 4. So these are the 5 values which are given to us. So that will be 7, 13, 9, 15 and 11. When we have to find the median, we have to arrange them in ascending order. So we will write the ascending order of the observations will be, first will be 7, then 9, then 11, then 13 and then 15. And these are 5 values, so your n is equal to 5, which is the odd number. So our median is given as n plus 1 upon 2th term. You remember the formulas. So that becomes equal to 5 plus 1 upon 2th term, which is equal to 6 upon 2, which means the third term. And the third term is 1, 2, 3, so that is 11. And that is our answer 2. So we finished 6a. 6b is factorized. 25a square minus 9b square plus 12bc minus 4c square. Shall we write it down? And then we will start solving. 25a square minus 9b square. Now this is a square number, this is also a square number, and this is also a square number. But this is the clue. 12bc, which means 9b square and 4c square. They have been used in this particular expression, and that is a perfect square. Let us see how. 25a square minus, we will take out this minus sign common, it will be 9b square inside the bracket minus 12bc, and this becomes plus 4c square. Now check, the middle term should be 2ab. Here the value of a is 3b, here the value of b is 2c. So if you multiply them and double it, so 2ab comes out to be 12bc, and so this is a perfect square of 3b minus 2c. So we will write it as 25a squared minus 3b minus 2c whole square. So you will see this is like your a square minus b square. So you will have 2 brackets. You will have a plus b and a minus b. Now 25a square is the square of 5a. So 5a plus 3b minus 2c will be the first bracket, and the second bracket will be 5a minus this bracket, so minus 3b, and this will be plus 2c. After this we cannot do anything more, and so that is our answer. Question 6c. In the given figure, ABCD is a trapezium. P is the midpoint of side AD, and PR is parallel to AB is parallel to DC. Prove that R is the midpoint of BC, and find the length of PR if AB is 12 centimeter and DC is 8 centimeter. First thing we do is we draw the diagram, ABCD trapezium, and P is the midpoint. So we will show this equal to this, and we write what is given. And also we know that PR is parallel to AB is parallel to DC. So we show with the help of this arrow. To prove that R is the midpoint of BC, so R midpoint of BC we have to prove, and PR is to be found out if AB is 12 centimeter and DC is 8 centimeter. Now, whenever I'm solving a question, ideally after this, you should put the video on pause, work it out, and then check it out. All right. So you have drawn the diagram, and now let us look at our solution. The first thing we will write is that P is the midpoint of AD and PR parallel to AB parallel to DC as it was given. We know that these three lines are parallel, and we have this AP and PD, they are equal to each other, which means they are equal intercepts. So even DQ and QB will be equal intercepts, and CR and RB also will be equal intercepts. But we have to come to R, so we will look at CR equal to RB. So immediately we write CR equal to RB from statement 2 and 3, where the three lines are parallel and equal intercepts are made because of the transversal AD, and so CR will be equal to RB because of equal intercept theorem. And because CR is equal to RB, R becomes the midpoint of CB. And that is what we have proved as the first part. Then for the second part, we have to find PR. So we are going to say PQ is going to be half of AB using this triangle, and QR is going to be half of DC using this triangle. Okay, so we are going to now look at DQ equal to QB again because of this parallel to this parallel to this, and these are equal intercepts. So DQ and QB become equal intercepts. See statement 2 and 3, that is here 2 and 3, and equal intercept theorem. Got that? And if DQ is equal to QB, then Q becomes the midpoint of BD. That is from your statement 6. Yeah. Now you keep the diagram in front of you because my diagram you will not be able to see. In triangle DAB, PQ is parallel to AB because P and Q are the midpoints of AD and DB respectively. And so PQ will be half of AB. This is from statement 1 and 7. Look at your statement 1 that says P is the midpoint and 7 says Q is the midpoint. And then we write the reason as midpoint theorem, that is MPT. In triangle BCD, you will see again Q is the midpoint of BD and R is the midpoint of BC. So QR will be parallel to DC and QR will be half of DC because of statement 7 and 5. 7 says Q is the midpoint and 5 says that R is the midpoint, and midpoint theorem. Now if you take this PQ and QR and if you add, you will get PR. Let us look at our diagram. See there, PQ plus QR. PQ plus QR is equal to PR. So we are going to add these two, and PQ is half AB plus half DC is this. So PQ plus QR is PR as we saw in the diagram. Half is common and here you get AB plus DC inside the bracket. The values of AB and DC are already given, and so you have half into bracket 12 plus 8, that is half into 20, that is 10 centimeter, and that is your answer. Question number 7A. Solve the following pair of linear equations using cross multiplication method, and here we have the two equations. Let us solve them. For the cross multiplication method, we have to bring all the terms to the left hand side, and we have to make it like 2x minus 5y minus 14 equal to 0. The second equation also, x plus 2y plus 2 will be equal to 0. So remember to convert this into ax plus by plus c equal to 0 in that format. So here we will have a equal to 2, here we'll have b equal to minus 5 and c equal to minus 14. And because it's the first equation, we'll call it a1, b1, c1. And this side, it will be a2 equal to 1, then 2y, so b2 equal to plus 2, so c2 equal to 2. Now, simultaneous equation for cross multiplication, we have to make b1, c1, a1, b1, and below that we'll have to write b2, c2, a2, b2. And now this side we will write the values. So B1 is -5, C1 is -14, A1 is 2 and B1 is -5. And below this, exactly one below the other, we will be writing B2 means 2, C2 means again 2, A2 means 1 and B2 once again it will be 2. Now we are going to write our formula. Our x is equal to, you have to know this by heart. It will be, write BC minus BC. So it will be B1 C2 minus B2 C1 upon, we will have A1 B2 minus A2 B1. And this side we will write y formula, which will be C1 A2 minus C2 A1 upon this denominator, and this denominator will remain the same. So A1 B2 minus A2 B1. Got that? Now to substitute B1 C2, we will do cross multiplication like this. So this will be like so. So -5 into 2. So we will write it like so. Minus B2 C1. So here also it will be B2 C1. So that will be 2 into -14. Then let us write the numerator here this side. So for this we will have C1 A2. So we will take this way, -14 into 1 minus C2 A1. So we will do C2 A1. So that will be 2 into 2. The denominator is your A1 B2. So we'll go this way and this way. So here it will be this way and then this way. So it will be these two multiplied. So 2 into 2 and minus sign and then 1 into -5. And the same thing will repeat over here. So 2 into 2 minus 1 into -5. Now it is simple. The only problem is this step. This you have to be very careful. This will be -10 and plus it will be 14 to 28 and denominator 4 minus into this will be -5, so +5. And for our y value, it will be -14 minus 4 and here it will be exactly the same 4 and here +5. So we will have 28 minus 10, that is 18 upon 9, which is equal to 2. And here it will be -18 upon 9, which is -2. So we have therefore x equal to 2, y equal to -2, and this is our answer. Some of your teachers may also ask you to write solution set as x and y values like so. Depends upon your teacher, and that is our answer. 7b. In the given figure, ABCD is a quadrilateral. A, B, C, D. This is the quadrilateral. BP is drawn parallel to AC. BP is parallel to AC and BP meets DC produced. BP meets DC produced at P. Prove that area of triangle AOB, that is this triangle, is equal to area of triangle COP, that is this triangle. And the second part, area of quadrilateral ABCD is equal to area of triangle APD, this one. In order to solve this, we will have to first draw the diagram on our answer sheet, and we have to also write what is given. So let us see how we write it. Given was ABCD is a quadrilateral. So we have ABCD is a quadrilateral and BP is parallel to AC. That's all we need to write. And then to prove that area of triangle AOB is equal to area of triangle COP. Now let us look at our diagram. Our AOB and COP. This is the purple triangle and this is the blue triangle. They have to be equal in area. Now if they are equal in area, then we must make use of these parallel lines. Okay, now look at this. If we take AOB triangle and if we add AOC to that, we will get this triangle here like so. This one. Okay, and if we are adding this orange triangle to COP, then we will get this triangle. Can you see that? Yeah. Now what can you say about ABC triangle and ABC triangle. They are having the same base and they lie between the same parallels. And so we are going to start writing our solution. Our point number 1 is that BP is parallel to AC, and that is given. Statement number 2, area triangle ABC will be equal to area of triangle APC, and this will be because of statement 1, and areas of triangles having same base, that is AC is the same base, and between same parallels, that is AC and BP, they are equal. Okay, now statement number 3, your ABC is made of purple triangle and the orange triangle, so we will write area triangle AOB plus area triangle AOC is equal to this one, APC becomes area triangle AOC plus blue triangle, that is area triangle COP. Okay, now this will be because of the diagram. Now you will see AOC from both sides, both the triangles will get cancelled, and then fourth one will have therefore area triangle AOB is equal to area triangle COP. This will be from statement 3 and proved the first part. Got that? Now next part, they are asking us area of quadrilateral ABCD equal to ABP. Now area of ABCD will be this triangle ABC plus APC, and area of triangle APD will be this blue triangle and orange APC plus ADC. So we are taking statement number 2, that is ABC triangle and APC triangle. To each of them we will add ADC. So to statement number 2 we are adding this area. So let us see how we write it. Statement number 5 is area triangle ABC plus area triangle ADC will be equal to area triangle APC plus area triangle ADC, and here it will be from statement 2 adding area triangle ADC to each side. Now let's look at the diagram. We have written ABC plus ADC. ABC plus ADC is quadrilateral ABCD. So we will write just that. Therefore, area quadrilateral ABCD is equal to, so we got these two. Now APC and ADC, let us look. APC plus ADC is ADP triangle. So that is area of quadrilateral ABCD equal to area of triangle APD, and this is from diagram and statement number 5 and proved second part. So that is how we solve this question. This was our 7B question. Now let us look at 7C. The cost of mowing a circular field at rupees 16 per square meter is rupees 2464. Find number 1, the total area of the field, the radius of the circular field, and the cost of fencing the field at rupees 12 per meter. So we write down the data, and remember it's a circular field. So I'll just show a diagram like this, and this is the area to be mowed, and that area for mowing costs 2464 rupees. So if I want the area, I'll say 1 meter square costs 16 rupees. So these many rupees will be for how many square meters? So we will have area of a circle will be equal to the total cost upon the rate. That will give us 2464 upon 16, and that gives us 8 2s, 8 3s, 8 zeros, 8 8s, 2 1s. So it is 154 meters square. But area of circle is formula wise, it is pi r square. So we got to connect it with the formula. So 154 is equal to 22 upon 7 into r square. Therefore, our r square is equal to 154 multiplied by 7 upon 22. 22 goes 7 times here. which is equal to 49. Therefore, radius is equal to 7 meters. Now, area of the circular field, we got this. We found our radius also 7 meter, and this was our answer 2. And then the third part is find the cost of fencing. Now the fencing will go right round, which means you have to find the circumference. So circumference is 2 pi r, which will be 2 into 22 upon 7 multiplied by radius is 7. 7 gets cancelled and we will have 44 meter. And so the cost of fencing at the rate of rupees 12 per meter will be equal to rate multiplied by the circumference. That will be equal to 12 multiplied by 44. It comes out to be rupees 12 fours 48, carry 4, 12 fours 48 and 4 52. So we have 5